Right, this here is the Docker Universal Control Plane UI, and you'll often hear people call it UCP for short. Anyway, there's some nice visuals that give you a quick idea of what's going on in the infrastructure. So we've got one app deployed, 34 containers, 86 images and 5 nodes. Then CPU and RAM, well, these are both suggesting that maybe the cluster's on a day off or something. Nice. But I would say, don't jump to conclusions here, right? These numbers here don't necessarily translate into those 34 containers being part of that single app. It could be that the app only comprises a handful of the containers, and maybe the rest are simply running without being part of what UCP considers an app. Or, actually, a bunch of these containers might not even be running, because I'm pretty sure this reports on all containers, whether they're running or stopped. And obviously, right, those 86 images, they're not all being leveraged by the single app. Anyway, this little puppy down here, this should be massively familiar to us. I mean, that is proper Swarm right there. Scheduling strategy spread. So, despite this being UCP, those 5 nodes are part of a single Swarm cluster, and we're running with the spread scheduling strategy, which we learned earlier is the default. Also, right, under cluster controllers here, check this out. 3 Swarm managers. Again, we know all about this. We know that one of them's got to be acting as the primary manager and the other 2 as secondaries, which sometimes you might see referred to as replicas. Anyway, if we skip over here to nodes. Right, so our 3 controllers and Swarm managers again, but then some details about them down here. But look closely, right, see how 3 of these 5 here are Swarm managers again, controller 1, controller 2 and controller 3. This is because the nodes that are acting as Swarm managers and cluster controllers in this setup are also acting as Swarm nodes. And that's totally possible. All you need to do on your managers is run a Swarm join process or a Swarm join container, and they'll register with the cluster as regular nodes as well. So yeah, 5 instances in AWS, 3 of them acting as cluster controllers, Swarm managers and cluster nodes, and the other 2 just acting as cluster nodes. But see the labels here too. Execution driver, kernel, OS, provider, and these 5 are all in AWS, yep, and then storage driver. Now, these are the standard constraints that we talked about before, with provider being something that UCP automatically adds, but they've currently got no custom labels. Well, if we scoot up here to containers, right, well, first of all, we can see that clearly only a few of those, I think it was 34, are actually running. This old drop down here is hiding the stopped ones. But remember, when it comes to scheduling new containers against nodes, Swarm's scheduler treats containers in the stopped state just the same as those that are started or running. And then maybe if we click this top one here, right, we get to see a ton of info. But I think what's of interest to us, well, there's memory reservation there that we saw earlier. Okay, this container doesn't have one, but it's there anyway. But if we go further down, right, we can see some custom labels. So this one is tagged for blue builds and for production. So yeah, just the tiniest of scratches at the surface of Docker UCP and Docker Datacenter. And we can already recognize a bunch of Swarm stuff in there. So now that you're cool with Swarm, getting up to speed with tools like Docker UCP is a whole lot easier. Alright then, now let's have a quick change of tack and look at how Docker Cloud leverages labels.